Okay, this is a lesson on the tan function. Now we know tan equals sine over cos. Okay, we proved that earlier in another video. So when you go to graph this, there's something, because it's a fraction that tan is equal to, it has certain properties. One, the denominator can't equal to 0. Whenever the denominator is equal to 0, you're going to have what's called an asymptote. The second thing is that when tan of 45 degrees is actually equal to 1. So that's going to help us out, as giving us some starting points. And when the numerator is equal to 0, the third thing is that the tan function itself is going to equal to 0. Because you have 0 over anything, the whole thing is going to equal 0. So let's start working through these and help create a graph. So I know I have an asymptote whenever cos x equals 0. Well, cos equals 0 at 90 degrees. So also at negative 90 degrees. At 270 degrees. So also at negative 270 degrees. Okay, and you can use the unit circle to help prove that to you. When does the top equal 0? When does sine equal 0? Well, sine equals 0 at 0 degrees, at 180 degrees, at 360 degrees, so also going back into the negatives as well. And tan equals 1 at 45 degrees. So I have 1, negative 1. 45 degrees, and it will equal negative 1 at negative 45 degrees. And asymptotes is going to get forever close but never actually cross. And that's going to continue into the negatives as well. It's going to get forever close but never actually cross. And this creates a pattern. It's going to repeat itself. And there's the tan function. It repeats itself. Now, it doesn't take the normal 2 pi intervals to repeat itself. That's not normal period. The period for tan is actually just simply pi, or 180 degrees. It has some asymptotes. It has some values that will not equal, that just do not work. You put in 90 degrees into tan, and it will become indeterminate. If you think about it, think of tan as being opposite over adjacent. From 90 degrees, you can't do it, because what's the opposite? Well, one's adjacent. It just doesn't make sense. So at 90 degrees, tan is undefined. So taking that graph, I can do some normal transformations. Now this transformation is your shift, your horizontal shift, left and right. It's positive, so you're going to do the opposite. You're actually going to move to the left 90 degrees. So take your, what you know of your tan function. I'm just going to quickly do these. Okay. And you know it's at zeros. So I'm just going to sketch my basic tan function. Now it's saying shift 90 degrees to the left. So that means everything's going to go to the left 90 degrees. That's going to be where my 0 is. This is where my asymptote is. This is where my other asymptote is. That's where the 0, new asymptote. So everything's going to get shifted 90 degrees, asymptotes included. Okay? So in red is what my new tan function is going to look like. Okay, I apologize for the mess. The red is the new one. Everything just got shifted 90 degrees, asymptotes included. Tan 2x. Okay, now what does that mean? That affects your period. Okay, and it's actually going to divide your period in half. So instead of having your normal period is just pi. Now your period is going to be pi over 2. Okay, so everything is going to get shrunk down, and as a result, we get shrunk down. Your tan is going to occur a lot more frequently. Okay, twice as often. Okay, because you're going to have everything being shrunk horizontally in half. So where your original asymptotes are, they're going to shrink in. And they're going to shrink in. Everything's going to be cut down into half. Okay? So your period was going to be every 90 degrees. It's going to repeat itself. Solving tan equations. Okay? And same as solving normal other equations. I have tan, my angle equals square root of 3. Now, I got the angle by itself already. Awesome. Root 3 is secretly root 3 over 1, which is going to come from the 1, 2, square root of 3 triangle. That's where those numbers come from. 60 degrees, 30 degrees. Tan is opposite over adjacent. Opposite over adjacent, root 3 over 1, so it must be tan of 60 degrees. It's positive, so C-A-S-T, so it's going to be 60 degrees, and it's going to be 60 degrees in that quadrant, and down here, so 240 degrees, which is pi over 6 and 4 pi over 6. So I know my angle, x minus pi over 6 equals, and it's going to equal pi over 6 as my first possibility, or 4 pi over 6 as my second possibility. Plus, I have to add my, because it's going to repeat itself, you're going to have multiple different other angles, so you have to add on the period. Well, the period, usually you do plus k2 pi, or 2k pi, or wherever order you want to put it. Well, this one you're not going to be able to do that because the period is not 2 pi. It's just 1 pi. So you k plus k pi. And if, you know, here I have an undefined domain, so I can just leave it as that. But if it was a defined domain, I'd have to add in different pi values on, to add on every 180 degrees to see if there's more possible answers. I haven't got x by itself. I got the angle by itself, but I haven't got x by itself. So I need to move this minus pi over 6 over to the other side and turn it to plus pi over 6. So I'm going to have x equals pi over 6 plus pi over 6. It gives me 2 pi over 6. Add on a pi over 6. That's going to give me plus 5 pi over 6 plus k pi. And just reducing, it's going to equal pi over 3, 5 pi over 6 plus k pi. Okay, you got to get x by itself. I got my angle by itself to start with. Then I had to get my x isolated. Okay? A few more equations involving tan. Okay? Now tan, we know, is sine x over cos x. So you might want to substitute that in sometimes. So if I'm simplifying, I see a tan, I have sine and coses in there. Let's get rid of the tan. Let's replace it with what it's equal to. Sine x over cos x plus 2 sine x. Okay, I have multiplying going on and dividing, so they can cancel out. So I'm left with sine x plus 2 sine x. Well, if I have 1 sine x plus 2 sine x, I'm going to have 3 sine x's as my simplified answer. Again, I have a tan and a sine x. I don't like the tan. I'm going to replace the tan with sine x over cos x divided by sine x. Now, I have a fraction divided by something. I might as well turn it into another fraction. I have a fraction divided by a fraction. Then I can flip and multiply. And when I multiply, sine x divided by sine x is going to cancel. Now I'll be simply left with 1 over cos x. Okay, if you know about reciprocal functions, you might want to go further. But if you don't, that's fine. Okay, and the last one, find sine x given that tan x equals square root of 5 over 3, and x is between 180 and 270 degrees. So what I want to do is I want to set up a little right angle triangle, because I want to find a missing, I have tan, but I don't have sine, I don't have cos. So I can figure this out. So if I put an angle x here arbitrarily, tan is opposite over adjacent. So I have root 5 as my opposite, my adjacent is 3. I can use the Pythagorean theorem of 3 squared plus square root of 5 squared equals, let's call it c for the hypotenuse, c squared. 9 plus square root of 5 squared is just 5. So 14 equals c squared, square root of 14 equals c, square root of 14. Now it's said that it has to be between 180 and 270. C-A-S-T. 180 and 270 is this quadrant right here. I want to find sine. Sine x is going to be negative, and it's going to be opposite over hypotenuse. Square root of 5 over square root of 14. But it's negative because of the quadrant it was in. And sine is what I was finding, but sine from your right angle triangle is opposite over hypotenuse. You need to find your hypotenuse. Okay, this is a little lesson on the tan function. Thank you very much.